right, welcome everybody to Dave Cooper Live, where we showcase the people, the products, and the processes to help us all build it better. And today we welcome Coraline Faurie with advanced degrees in engineering and practical experience in computational fluid dynamics. She started her career in fire safety engineering and moved on to offer special services for the construction industry, including modular design, sustainability, fire engineering, and CFD. She then took a key role in developing a ConTech product, promising to deliver a digital product-first approach to solve for the housing crisis, which begs the question, can you deliver on transformative construction technology without the right team? Well, before we break down this approach to solving an incredibly complex problem like the housing crisis and the dangers of being fully consumed by the task itself, let's thank our supporting members that allow us to bring you all of these innovative conversations each and every week. Forward Solutions Group is successfully driving companies to succeed where others have failed. Are you looking to start a factory, optimize your existing factory, streamline your production, or take your team to the next level? Whatever your needs are, Forward has a solution for you. Reach out to Ben at forwardsolutionsgroup.com. Halleck Ltd. has a long history of innovation in cold form steel manufacturing and producing innovative precision roll forming technology for customers throughout the United States and the world. Check out their machine buyer's guide for off-site modular construction or fast build construction with light steel for framing. Go to their website, halleckltd.com. Brought to you by Greatech, one of the largest Autodesk partners globally and software developer of the PowerPack Advanced Design, Advanced Steel, and the StruxSoft product line. The complete solution to automate wood and light gauge steel framing, design, and documentation all the way out to CNC output, model, design, and manufacture with StruxSoft. Learn more at StruxSoftSolutions.com. All right, again, a big shout out to all of our supporting sponsors and members. Thank you so much for everything you do to allow us to continue these conversations. So without further ado, let's bring in Coraline for this awesome, and I mean awesome, conversation of some great tech. Coraline, how are you?
I'm very good. Hi, how are you?
Yeah, I'm doing great. Now, you kind of said that, hey, I might have to do my intro a little bit in French. So if you do speak a little French, that's fine. Let's have some fun with it. But I'm looking forward to this conversation. And like I said, before we get started, we want to know everything about you from the moment you were born to this very moment in time, Coraline. And do not leave out any of the good stuff from the hospital, or we will have your parents on the call with us. And I know they don't speak English because you told me that, but I'll have a translator on. I promise you that. But you only got 2 minutes to do it, so the floor is yours.
Thank you very much. Hi, Dev. So I'm Coraline Faurie, and I am French. I actually studied in Toulouse, south of France, and that's when I had a master's degree in fluid mechanics. So my background is in fluid mechanics. And that's where I decided that actually I wanted to live in New York. I didn't want to live in France anymore. So that's why I started to look for other studies and other schools around Europe. And I found a very interesting CFD degree at Imperial College London. So that's why I moved to London originally, then move on to New York. But I fell in love with London and I stayed there. So I've been living in London for 10 years. I entered the construction industry as a CFD engineer. So CFD stands for Computational Fluid Dynamics, and it's basically modeling fluid movement through computers. I've done that for the most part of my career. And then I worked for a consultancy business, boutique engineering consultant business called Optimize. So that's when I was doing CFD engineering, and realized all of the problems with the construction industry. CFD engineering is really around creating better building, optimizing the design, making sure that everything is really well performing, really comfortable for the inhabitant, and very optimized in such a way. And I was very struck by the inefficiencies in the design process, the inefficiencies in the construction industry overall. So that's why we decided to create a business called Modular that had modular construction in it. And then as part of that, I created a software called Tessa. And that software, it's a web application that automates feasibility and early stage design for modular construction business. So that's what we're going to talk about today, I believe.
No, we are going to talk about today. In fact, we're going to get into all of those different things, modulus, Tessa, but first let's talk about what is the overview of Tessa, and what were the main objectives when you were creating?
Yeah. So Tessa is a tool that uses generative design to automate the feasibility studies of residential construction building. The tool was really the objective was really twofold: to speed up the process, the design process, as much as possible, and to provide as much data and accuracy earlier in the design phase as possible. So the automation, the generative design helped with the speed and helped with automation and creating things a lot quicker than what traditional workflow did. And using a kit of parts, using a build system that was engineered and proven and had, real project data linked to it, helped with the accuracy and the de-risking the process. So if you compare it to a traditional workflow, it would take you a few weeks to get to feasibility studies and design up to planning or permit. And that would be based on square rates, based on very minimal information, a lot of estimation, a lot of guesswork. When using a software like Tessa, you could have this like a superior level of design with more information, more data, more accuracy in a matter of minutes.
So let me ask you this about Tessa and then I know we got a short little video you're going to walk us, show us some of that. Why don't we show that video first, and then I'm going to get into some of my questions on the product itself. And
maybe I can explain what we're seeing on the screen here, if that helps. So it's basically how you use Tessa. So you start by logging in, you search for your location. It could be, anywhere on the planet, but the regulation and rules that are built in Tessa apply to the UK. And then you enter your site. So you either draw it or so you draw it on the site, or we have access to land registry, which is the equivalent of zoning data that define your site. And then based on default parameters, or you can, change and define your brief. And based on that, as you can see on the screen, it's going to automatically generate multiple what we call design options. So it's fully engineered building layouts with a cost plan, with carbon metrics and technical drawings in a matter of a few minutes. You can then export those to your current workflow, or you can modify them if you wanted to. So if you wanted to have, additional floors or rearrange something in a more manual way, you could do that too.
So how does one actually go about creating a tool with the idea or the intention of, kind of transforming an industry, right? Because here you weren't in the industry, you kind of saw the inefficiency in the industry. So that's my first question. Then my second question is going to get into parametrical and generative design. And we've seen programs similar to this in the past. And I think it'll be really important to understand, is it the same or is it different? But first, let's talk about, what happened in your brain that you said, yeah, I want to tackle this problem and start to, building a team and putting this together. Yeah,
of course. So as I said, it's because I had an overview of the design process and how things was done that I was really frustrated as a CFD engineer. As I said, maybe I can talk a little bit about what is CFD. Is how you model fluid movement through computers and through simulation. So I was doing a lot of fire safety engineer, modeling smoke movements and ventilation system to make sure that people escape the building safely. Or it's around modeling wind movement around towers to make sure that the structure is strong enough, or that people at the ground floor are really comfortable. It could be wave loads on jetty. It could be all sorts of things that interacts with fluid. But basically, if you want to optimize something, if you want to build the best building possible, the most optimized building possible, it's kind of easy to understand that you need to interact really early on in the design phase. You really need to do something as early as possible and work really closely with MEP engineers, with architects, with structural engineers to make sure that all of your recommendations are taken into account. What I saw is a lot of repetition in the processes, even in the architect studio and the MEP people, a lot of repetition. They don't talk the same language. When people work in 3D, other people worked in 2D. They have different models for different things. The communication is broken. And then someone like me would be called on very, very late in the design phase because it was to fix an actual, like a problem with authority and something like that. So the mindset was not right. And processes were not optimized. So when we looked at this overall, there were a lot of opportunities to improve the current situation. And because we had a physical product, the kit of parts, we had a lot of data even before we selected a project that could help solve some of the problem. So that's where the idea came from. The idea was not me thinking, I want to build a software, what can I do? It was really like, that's the market, that's the industry. We think there is a really great opportunity to utilize the data coming from the kit of parts to speed up the design process and make it a lot nicer. So your question was, how do you go about doing it? Well, you start with the beginning and you start by trying to build some prototype to theorize what you have in your head and trying to think if it's actually possible, if the technology is there yet. So that came with some parameter modeling that I did. So that, to answer your question, parametric modeling is, parametric design is basically you have one parameter that you vary and that will vary your design. So for example, if you have, I don't know, a bridge and you have the curvature of the bridge, you can say that the radius is a parameter that you move it, and then your bridge is going to basically be either really arched or really flat, depending on that parameter. That's parametric design. That's, you know, it could be very, very simple, but you can think about models with multiple parameters, very complex equation, where, you know, it becomes a very complex model and very complex design. What I call generative design, so what Tessa utilizes generative design, is the idea that you would learn from your previous iteration. So you would generate a bunch of design, you will see how it satisfies your objectives, and then you will learn from this design how you can get better to solving this objective. That's the idea of generative design. All I'm saying is that we created algorithm that took the Lego piece, the kit of parts, the module, to automate the creation of building from this module and Lego piece. That's what Tessa was doing. You're on mute, Dev.
So let's talk about the modularization of what Tessa does, right? So here it is. Walk me through the start of this. So before you can start, how do you get the parameters of the property in there, right? So you have civil engineering or surveyors. Where does the project start? And then I want to kind of walk through how this is actually able to take and build all these different designs based on the modeling, based upon the kit of parts that you guys have already sourced. And then I want you to explain, is that the difference between what Tessa is doing and maybe some of the other ones that are out there?
Yeah. So Tessa starts a very, very early stage. So you would go in, similar to Google Maps, you would look for an address, a postcode, whatever. So you have a map on a screen, and then you zoom in into your project location. Either you draw it on the map, or we have also digitized what we call land registry data in the UK, which is equivalent to use zoning data, I believe, in the States. So it's basically legal title for your state. So you could select that, and that would basically create your site. So that's the outside boundary of your site. Tessa allows you to then slice it into different chunks, depending on, for example, if some of the site is going to be a taller building, other parts of your site are going to be more affordable, for example. So if you have different, like a very big site with different parts and different orientation, or you can even create like a pathway in the middle if you wanted to. So you can create that manually with the user interface. And then you enter a bunch of parameters. So you could say you could switch to satellite view to understand what's going on. And then from your survey data, you will understand the parameters of what's possible and what's not possible. And that's when you decide the brief. So the height of the building that you want to achieve, the mix, so the proportion of 1, 2, 3 beds apartments, and all of those parameters. And then that would be used to automate the generation of those design options that I mentioned before. So that's what it does. What was your other question?
So, you know, once you have the data, once you have the site data, right, and you can bring in all that site data, you know, is that a manual entry, or are you just pulling the Revit file or the Autodesk file to pull that into your system? And then from there, how do you set the parameters of what you're building?
So it could be either or. You could either upload it, or you can set it up through the user interface. So it's basically, you have a form. It's the equivalent of a form, and you click on a few buttons, and you have sliders to change the height of your building. So you can also iterate. You can try different things depending on, you know, different options, and you can save them, and you can go back to it, and you can iterate a few different things. But yeah, the brief is basically what the user wants. Some people would want to have certain type of building, other people would want to have other types of buildings. So it's a manual input. What do you want to see on site? What do you want to build? What we have hard coded is all of the rules and legislation around what's allowed. So for example, I'm going to talk about UK regulation here. It might be different numbers for the states, but the theory is the same. You have certain distance of corridors allowed for fire safety reasons. So you can't go longer than certain length, depending on whether you're building a sprinklers or not, depending on the total height of your building, depending on how many units there are in the building. You've got certain regulation. All of that is hard coded. So that means that the design options, the building that we put forward, are compliant against UK building regulation. So you don't have to think about those things. Similarly, we also do volumetric allocation of amenities, technical spaces. So technical spaces is MEP, technical room, tank room, electrical, all of that jazz. We do cores as well, so that the core around it is sized so that it can fit all of those technical spaces, dry risers, and all of that. So all of that is hard coded. You don't have to. So what we want to do with TESA is definitely not replace anyone, is allow the architects to be creative, allow the property developers to really worry about what they need to worry about, and don't have to repeat the same work that they're doing. Like the regulation are the same from one project to the next if you are in the same location. What we wanted to do is to simplify the process, to speed up the process so they can spend and focus the time doing what they want to do on the creative part.
So let me ask you this then. So you design the building. Is what separates you from other generative designs out there is that you have also tied this to a kit of parts for people to manufacture these buildings. So there's a whole circular system in place. So this could actually go to production. Yeah,
that's correct. So that's the unique selling point of TESA, and that's what makes it different from other generative tools out there, is the fact that all of the design options that we generate are based from a built system that is proven. So if you think about it, you have a design options with, I don't know, 4 buildings, 500 units on this building. A traditional feasibility tool will basically have a pound per square meter or dollar per square meter per square foot rates apply to this, and that would be how much it costs. What we're doing is we utilize all of the data from the kit of parts, so how much is still cost from the supplier data as well, so all the live data from the supply chain, monthly updated with market data, and all of that is built in the cost plan, so that the cost plan that are automatically generated with all of the design options are as accurate as possible at this stage of the project. So that allows us to go more accurate and de-risk the feasibility study that we put forward, so that we have like the difference between the cost plan that we generate and the cost plan, the actual cost of the building at the end, is a lot closer together than with a traditional process when you don't have access to all of this data.
Very cool. All right. So now we have the kit of parts. You have the design. Does the design take in account and include the MEPs such as electrical, wiring, plumbing, dry stacks, all of that stuff, or is that separate to this?
No, I mean, in we had to start somewhere, and that's obviously very important. So what we did is volumetric allocation for those rules. So for example, you know that a building of a certain height and certain magnitudes with a certain number of units is going to need a tank room that is X meter cube. That's what we did. That's built in. You don't have to think about that. All of the technical, so the tank room, mechanical room, communication, electrical, at dry riser as well, the space that is required to allow those in the building is there. That has been done. What hasn't been done is the specification of what goes inside it. So and also the connection, the horizontal connection from the dry riser to the flat. That is something that was in the roadmap. Is obviously something that we wanted to work on and would be very, very powerful. But it's not something that we've done yet. It is not that difficult. It's just a matter of time. And the other thing is for volumetric allocation, obviously it's going to be very dependent on the system that you're using and the type of building that you have. So for example, if you have a sprinkler buildings, you're not going to have the same requirement for the tank room that if your building is not sprinkled. So that's also taken into account. We have a default system used that is widely common in the UK, but the user can change the type of system that they want. If they know what they want to use or what the project what's the requirement of the project, they can change that default system, and that will automatically update the design accordingly.
So it doesn't include the mechanicals. What it's including is the space for all the mechanicals. So it takes into account what's going to be needed to make sure you can run your horizontal and vertical lines to each of the units, the modules that are coming in. Is the kit apart built around modules as in a modular design approach, or is it built around a panelization approach?
It's a module. So what we have is a module, and it's modules stacked together. Actually, the what we use in Tessa are flat types, apartment types. So we have a kit apart. We have modules. Modules put together can make flats, and that's the layer that we use. So we have library of standard what we call unit, because it's not necessarily a flat. If you think about the concept of Tessa and kind of try to think about opportunities, you can think about student accommodation or hospitality, or it could be classroom or whatever. So that's why we call it a unit. But a unit is a standard unit. So we have a number of 1-bed flats, a number of 2-bed flats, a number of 3-bed flats. Sorry, excuse my French. Is that how you say it?
That's how we say it. Called after a bad word.
Very, very fitting. So you have all of those, and that's what we use to create the buildings. And those flats are based on the kit apart. So it's the structure is built in. Yeah.
Got it. So walk me through how this works, right? Because here you've developed, this programming that, works with this kit of parts, but where does the kit of parts come from? And how does that kit of parts in your system go to a manufacturer? Can it go to anybody, or does it have to be with a company or a manufacturer within your current ecosystem?
So the kit of part that we used in Tessa was the modular kit of parts. So we can talk about that in a minute if you want to. It's giving more data and more flesh for Tessa to use, but Tessa can be used as a standalone product. At feasibility, you may not have necessarily chosen what build system you want to use. You can use it independently from the kit of parts. If you wanted to actually build your building, you could, go to the kit of part manufacturer and do it. The model that we had at Modulus is a decentralized model, so that we have local assemblers and they can work with you on the project local to your project, so that we didn't own the supply chain or any of that. But you can think about any model that you would want to see. So if you switch to a different kit of parts and someone who had a supply chain, then you can go to them and they can carry on the building. We also we also made sure that you could integrate with your workflow, because we don't do all of the design phase. We didn't do all of the design phase yet. We wanted to make sure that it was integrated with people's workflow and that no work was lost. So all of the design options that you created in Tessa could be exported into IFC or Revit format. So Autodesk Revit is the standard BIM software, and that could be directly imported into Revit. So for example, say you do a lot of work at feasibility stage with Tessa, you create all of your design options, you change, you make them your own, you kind of sure that that's what the option that you want to go for, and then you want to progress forward. You can export it, import it into Revit, and that would have your Revit file, Revit model directly set up. You have no manual input whatsoever. All of your area schedule, all of your technical drawings are automatically pre-filled, and you can just carry on with your traditional workflows, no problem at all.
Does the program itself allow end to end, or is it just in the design portion of it, or does the program follow it all the way through the actual completion of the project?
No, it's just the design. It's just the design phase. It's just early design phase all the way to planning.
Yeah.
Obviously, the idea, the vision for the product is to was to add more and more functionality. So, what we just talked about was the MEP design, and to have the connection, the horizontal connection, that was next on the roadmap. And that's because we need that to progress into further refine the design options that we had, and to have more and more of the design process as possible in the application. So that's exactly what we wanted to do. We started at the feasibility stage because we wanted to allow the physical kit of parts to develop, and because we had to start somewhere. So that's where we are right now. But we wanted to include more and more of the end-to-end process as possible.
How does that come? Like, say here I am in, France or England or wherever, this is currently was operating. I want to be involved, right? Here I am. How do I access this? I'm a designer. I'm an architect. I'm, a general contractor with my own engineering design team, whatever the case is. How does one start taking part in a program like Tessa?
It's a SaaS product. So you buy a license and then you start using it.
And you're in.
Yeah, you're in. Yeah. It's a web application. So it's available from any browser. You can just, open a tab at Tessa.ai and you're good to go. You don't need any special hardware equipment. You just need the internet connection. That's all you need. We even wanted to do it mobile. It works kind of in mobile. It's not optimized for mobile, so I wouldn't recommend it. And it's a bit fiddly to draw your site on your mobile. So I would recommend a laptop or web browser.
Right.
But yeah, it's a web application. So any SaaS product that you can have.
Sure. So let me get this right? So one, I can speed up my design to doing something within minutes, right? As opposed to weeks and weeks and weeks of design and back and forth. I can do that with certain accuracy, using the kit of parts. I can do that with certain pricing guarantees within a certain amount of percentage, depending on fluctuation of market, pricing and all of that. What am I missing here? What are some of maybe the challenges that you're seeing, or what are some of the limitations to what one can do with a system like this?
Yeah, very good question. And that's something that I've really wanted to explore. It's the whole idea of, and you touched on it a few times as well, when you asked the question about, what if you are a modular provider, what about other kits of parts? Are you tied to it? The vision, what I wanted to do with this web application is to create an ecosystem. What I wanted to do is provide, at the moment, I think it's missing flexibility. It's missing the ability for a property developer or an architect to come in and to say, actually, I may not want to do multi-story, multi-family residential building. I might want to have, a school, because it's a very, very big site and I need to allow for school, or I want to have a hotel instead, or I want to do student accommodation or co-living. All of those different tenure types that are very important to a society at the moment, because Tessa was limited to the modular kit of parts, that was impossible. But that was the whole product vision, is to be the first step we have we build the foundation based on a single kit of parts. Once we've proven the foundation of that, the technology advancements are required to do that, which we've done, then that's when we can explore other kits of parts and create that ecosystem. So digitizing other products, allowing the user to have access to multiple Tenotype. So you would log in, you would create your site the same way as you do it now, and you would basically say, do you want timber? Do you want CLT? Do you want light gauge steel? Do you want, and then once you select that, do you want to create a school? Do you want to do, as I said, student, other Tenotype, etc.? And then you would carry on with the product. So that, I think, that would be would have been a very, very interesting challenge. And it's something that I was really itching to try and see if we could crack it. Because we developed Tessa to be able to, investigate and try to work on this thing. So yeah.
Well, and we're going to get into this here in a few minutes as well. But, with the company, there's been some recent news about Modular and kind of closing its doors and, along with that, Tessa. But I think the information is still very valuable. And I think understanding how this information actually came about to build such a really cool, tech tool that can be used the way you guys have designed it with the kit apart, but also with, there's you, right? And you have this idea and, one of your things is, the role of a CTO to code or not to code, right? But then you have the relationship of the team that has to pull all of this together and how this gets built. So, before we get into what happened, or why, the doors closed, or even if we even get into that, it's really a conversation to me about, the technology now exists. We know it can be built, right? And I think this is what's really cool, and you guys have proven it. So why don't you talk to me just a little bit about, what kind of team does it take to build something like this, first of all? And, then let's get into, the culture of the team that has to understand how this all comes together. Because my guess is it's not easy to do.
Yeah, it was a project. It was a very big project, but it was a great project. So I started on my own 2018. We founded Modulus end of 2018, something like that. And it was very much at the beginning of Modulus, it was very much all effort was on the physical product, the kit of parts. And I was on my own with the technology side. And with Emily, a UX researcher who I worked with at the very beginning. She had just started, and together we just, start to look for, explore the market. At the very beginning, it was not even UX. It was nothing. It was like, what can we do? What is the market? What is the demand? Where is the demand? So we interviewed as many people as possible. The COVID crisis, the first lockdown, was actually quite useful for me because that opened me doors to people who wouldn't have spoken to me in a normal setting. So a lot of people had a little bit more time on their hand. Video calls started to be widely spread. So that allowed me to talk to a wide variety of people and really understand what the pain point was, what the mental model was, like how can we actually crack the problem? It's so big, it's so ambitious. How do we go about it? Where do we start? And it was a little bit like rabbit hole. Every single time I tried to draw the process and the specificities and all of that, I fell into a rabbit hole and I was like, oh my God, this is so complicated. So it's actually about going back to your objective, going back to what do you want to do? Okay, what can I do now? The first thing that was complicated is to get access to fund. So we did a little bit of that, and we had a loan from Innovate UK, which really helped us out. The building the team, to go back to your original question around the team, it was very clear to me that I had a very strong product vision. I knew exactly what I wanted to do, what I wanted to achieve, and I knew the requirements for that. So I knew I wanted to have a web application. I knew I didn't want a desktop app. I wanted to be innovative. And at the time, a web app was the only way forward for the ambition of scalability and security and and the ecosystem that we wanted to build. It had to be a web application. We knew that it had to be a very solid rendering capabilities, because the planning permits and every stakeholders in the design phase are very interested into really nice renders. They want to see what the buildings look like in context. They want to really understand the feel of it. So it had to be based on the 3D rendering capability. So we explored a lot of technology around gaming engine. That's what our web application relied on, a library called WebGL. So it's environment created for games. It's a gaming engine originally, and that we basically use for the construction industry. So that gave me, and I knew that I had all of the keys of our data as well that I had to stitch into the application. So they gave me a list of requirements, and that gave me, the skill sets that I need to look for in the market. So the first person that I recruited was a data architect and a WebGL specialist. So that was a programmer, rock stars, both of them, absolute legend. And that was that was my first problem to solve. Okay, how do we put all of the data that we have into an architecture that can be digested by a computer? And then where do we start with the algorithm in a web environment? So that was the first thing. And then we knew that we had to store this data somewhere. So that when the backend aspect of it started to play, so that's when we recruited backend engineers. And then we knew we had to create a front end, so user interfaces. So that's when we recruited front end engineers, and we grew and we grew and we grew. So to give you an example of timeline, the GitHub organization that created Tesla was started in June 2021. And that's when I was on my own with UX designer, and that's when we recruited the first two people. And we launched the commercial version of Tesla in May 2023. We were a team of 15 at that point. And I only grew organically. It was very much, I wanted to remain very lean. I wanted to build relationship, to build collaboration, and to create, to really grow organically with the project, to avoid having over engineering, to avoid, to keep everyone very motivated as well, and really understand where the skill sets were needed. I wanted to say something, but I forgot.
Yeah. So, I think the team is super important and by far when creating this, but let's kind of get to where we are today, right?
Yeah.
And kind of, what happened. And we've been talking about this show for a while. I think, where do you go from here, right? Where do you take all of this knowledge, all of these applications that you've developed, in your mind and with your teams and all of that? Where does the, Modulus, Tesla, or any of, this go from here? Like, what do you see?
Yeah, so it's public information now, I think. So Modulus went under last month.
Right.
So it's very unfortunate. It's not the first one. It's not the last one. It's a very tough economical context. We had a project that was really hard to finish. It was really cash intensive. The economical concept was not in our favor. So unfortunately that happened. I still think that there is tremendous value in the tech, in the knowledge that we acquire, in the team that I build. I'm not sure what's going to happen next. I'm not sure in what format it's going to happen. I just know that it worked. That's the most frustrating in all of this, is that Tesla worked, and we had a clear path forward to make the ecosystem that I mentioned before. We had a clear path forwards to make a difference in the industry, an impact in the industry. I don't know in what shape or form, but I know that it worked, and I think it would be a terrible shame to lose the technology and to lose that.
Right.
So I'm sure something is gonna come out of it, whether it's through, Tesla, whether it's through another company. We build knowledge, and this knowledge needs to be re-injected in industry somehow, so it could be used for
right. Yeah, I mean, for sure. Listen, I mean, yeah, it's heartbreaking to hear that a company didn't, make it. But on the other side of it, there's a lot of good, like you're saying, that has come
Mm,
out of the work that everybody, put into it. And I think, that's a very, very important thing to remember because again, there's a lot of parametric design out there. There's a lot of generative
mm,
design, DFMA, all these different, buzzwords, computational design. But I think the difference in what you guys have accomplished was not only did you do that generative parametric computational design work, you actually tied it to a kit of parts that was
mm.
buildable. And to me, that's what has me most excited about this conversation, right? Because that's the hard link to make, I think, which most people had. Is that an accurate saying?
Yeah, I think so. And I think there are like, and we've seen it from the moment that we launched. We launched at UK Reef last year. From the moment that we launched, all of the conversation, all of the leads, everything was around Tessa and the number of modular provider out there who would benefit from having this as a BD tool, or to be in context with the people building the project, with the people with the money to build the project. That's tremendous opportunity here. There is definitely something that needs to happen in this space, and I'm sure something will come out of it.
Yeah, yeah, for sure, for sure. Well, listen, you made a comment in our pre-show, and I just want to read it because I think it's really relevant, knowing that you spent all this time, and then the doors got closed, which I thought was actually a really interesting way of looking at things. You said the danger of being solely defined, and I'm reading your words exactly, or by
Right.
what you do, to be consumed by your job when you invest so much of yourself in a project, and why this is not a good idea, even for
Mm,
the company that you work for. However, to recover, or how to recover, is one of the
yeah.
questions, and can you recover is the
Yeah.
next question. So when I read
Go.
that,
I went deep.
you're dumping your heart soul out, on the table here. But I think it's very powerful to know because, hey, listen, mental health, the workflow, everything that goes into what we do each and every day, even a smiling guy like me that's on camera all the time, there's stress, there's stuff that happens behind the scene. This is a really great question people should be asking themselves.
Yeah. I mean, yeah, I went deep with that sentence for sure. It really went from the heart. I mean, Tessa, I am not gonna lie, Tessa was my baby, it was my idea, was my like the team that I built. God, we had such a good, like I can't stress it enough. We had such a good team.
Right.
It was going so well. So it is like we went through really tough time together as well. It is challenging to have an idea, a very ambitious, big idea, and then within 2.5, 3 years, turn it into an actual commercial product that has the potential to change an industry. That's, I mean,
Yeah.
it's obviously it's not going to be smooth sailing and it's not going to be 9 to 5 all the time.
Right.
So, and because I was very invested, like I'm passionate by what I do as a person. I get invested, and I think I like transparency with my team, my people, and I emulate, like I kind, my mantra is kind of like give what you want to receive. So I worked a lot with respect, and I respect a lot of people where they are clever and when they put in the effort, when they're committed. So that's what I put into my project and my people as well. So obviously along the way, you might find times where you lose yourself a little bit, and you wake up one day and you kind of like, who am I? Like if I get hit by a bus tomorrow, I said that to, I think it was a friend of mine, I can't remember, but I said, if I die tomorrow, on my grave is going to say, she worked hard. And that's not something that I wish on anyone. You need
Yeah.
to have balance. You need to, figure out a way that you want to pour your soul and your heart into your project, obviously, because we work every day and we want to make a difference, but you also need to create that balance. And actually, I'm saying it's not a good idea even for the company you work for. I was saying that because my team told that to me when I was really deep into it, really like almost burned out from all of the work, all of the stress. And then suddenly, like I took a step back and I took a breather. And 2 months later, I had the same conversation with my team. They're like, you're a different person. You're a lot more relaxed. You're a lot more chilled. It's like everything was just easier. it was not as complicated, and everyone was just happier. So that's why I'm saying it's not. And the how can you recover? Yes, of course you can recover, and you learn along the way. That's we grow. We human beings. That's I wish that on everyone to grow through their experiences. But it will always be part of me. Tessa is part of me. So that's why I'm saying, yeah, it's my experience. It's how I enter the world now.
Right. For sure. And I say, work can be a labor of love, right? So I think that's a big thing. And I think everything you're touching on, probably most people watching the show have felt that sometime over their careers. So, well, listen, we're going to get to a couple comments and questions here. First, let me make a quick announcement, on some upcoming folks we have coming on. We have Alicia Huey, who is the chair of the National Association of Home Builders, coming on Monday, February 5th. I said the 15th last show. I must be losing my mind. February 5th. And she's going to be talking about NHB and how it is helping home builders deal with the soaring mortgage rates, inflation, and much more. And then on February 7th, we have Jacob, I'm going to get this wrong, Rukusin of New Frameworks will be on February 7th. And we're going to be talking about straw bale installation and panelized construction. That's right. They're building with straw and bale hay and all that fun stuff. It's going to be awesome to watch. And guess what? They're already manufacturing. So, and we will also be seeing you at the International Builder Show. So if you are attending, send us a message so we can meet up. But more importantly, if you want free passes to the show, and I'm not just talking free access pass, I'm talking educational passes worth hundreds and hundreds of dollars. And you got to tune into the show. We're going to be giving them away starting next week. So you do not want to miss that. So, all right, perfect. Got that out of there. Let's get back to the show here with Coraline. Coraline, let's go to a couple hellos that are out there. And then I got a few more questions to wrap us up. Ben Hershey, Forward Solutions Group. How are you, Ben? Dave Cooper and Jennifer Crocus Cooper, thank you for continuing to bring relevant information to the industry. Well, we appreciate you too. And if you don't know Ben and the Forward Solutions Group, well, you should. They're out there helping all the manufacturers in this industry to constantly grow and move forward. So check them out. And they have been a proud supporter of Dave Cooper Live for a long time. So thank you for joining us, Ben. All right, moving on. Christoph Dros. Oh, we're going to Poland, are we? That is a great way of creating optimized feasibility. Would love to test it. We had a few products like that before and even created our own linked to Revit, but was never better than our architects, to be honest. What's your thoughts on that?
We're not trying to be better than architects. Absolutely not. Like the first 6, 7 probably year of Tessa was to actually speak with architects every day, all day, and understand where they were coming from, where they were like in every, like look at them working every step of the way, every single time they made a decision, really question, why have you made a decision? Why is this that way? Why is it not that way? What information did you use to make that decision? What do you think is going to happen after you made that decision? It was like, it was very fictitious at the beginning because no one is, like, when you have 20, 30 years of experience in your field and you're an expert in your field, you're not used to being questioned every single time. And you're kind of like, because I know, because that's what we do. And having everything, taking apart and question like that was, very interesting. But now the architects are the biggest advocate for Tessa. So no, we're not trying to be better than them. We're trying to enable them to do what they want to do.
Awesome. Christoph, thank you for joining us. And I know we'll see you at the International Builders Show. I just heard. Looking forward to it. All right. No stranger to danger. You're going to have to read this next one, Coraline, because it's well out of my language barrier, right? The French words I know usually aren't the ones people want to hear.
Impossible n'est pas français. Impossible is in French. Basically, French don't do impossible. Like everything is possible when you're French.
Everything's possible, and big brain. That's what he said. You got a big brain. Is that what he's correlating to?
Thank you very much. That's all I can say. I appreciate the compliment.
All right. Good to see you, Henry. Let's catch up. Always a pleasure. All right. We got Gregory. Hello, Dave and Jen joining us. It's good to see you, Gregory. Thank you. Hey, we got the past chair of the NAHB. No stranger to this show, though. Great job, DC Live and Coraline. Great in-depth information. Love it when Greg joins. He updates the president and secretary of housing when he was in office several times a year. So he is no stranger to danger in Washington, D.C., that's for sure. Perfect. Hey, and Jennifer had a comment here as well on YouTube. We know who Jennifer is. You're hiding in YouTube, huh? Coraline, you talk about your team being incredible, smart, supportive, passionate, dedicated. What about the rest of the team? Was it a collaborative, supportive, etc.?
Yeah, it had to. So we used a lot of experts built into Modulus to do tests. So I spoke about the architects and the example before. We had in-house architect. It was really interesting because at the beginning, all I did was make them talk about their pain points and their processes and what they wanted to do. So everyone was very willing to talk to me about what they had in front of them and how they saw like what opportunity they could see in the industry. So that was very interesting and collaborative. And then we went on doing the big work and doing the tech and, questioning all of them. So at the beginning, it was a little bit like, technology, is it a magic wand? And then suddenly something appears. They don't not everyone really understand how it works. But with time and conversation and communication, Tessa is very cool. So we had a lot of support and a lot of collaboration from the rest of the team, to be honest. It was a fantastic team, for sure.
Awesome. All right. Last comment here that we're going to get into today. We're running out of time. Peter Molinar. How you doing, Peter? Great new technology to use for best outcomes. Watching from the North Shore of Lake Ontario. Man, it's cold up near Lake Ontario. I guarantee it. It's cold in Pittsburgh. Thanks for joining us, Peter, for sure. All right, Caroline, I got two questions for you. The first is, where's the team now? And do you think you can get the band back together? I mean, what are you going to do? That's that side of it. And then my last question is going to be, if there's one thing you wanted to leave with everybody out there, what is it? But first, can you get the band back together?
I mean, why not? I'm going to say, why not? Everything is possible, right? Or impossible n'est pas français, to quote Henry.
That's right. Everything's possible if you are French, for sure. So
exactly.
I love it. Coraline, if there's one thing people should take away from our conversation today, or if there's one thought you wanted to leave with our audience, what would it be?
We talked about a lot of things. I think there is value in failure as well. I'm super motivated and I'm super enthusiastic about the future. It wasn't the case a few weeks ago. It has been difficult, but now I'm really looking at the future and what's ahead. And I really think there is something bright and shiny for me and everyone else. So yeah, positivity.
There's always good that comes from, different situations, good, bad, or indifferent. And I've learned that over and over in my life. So I do believe that. And I think anybody would be happy to have you on their team, regardless of what you and your team end up doing, in my humble opinion. All right.
Thank you very much.
Coraline, do not go anywhere. Thank you for joining us today. And for the rest of you out there, make sure you say thank you to these sponsors as well, because you can't get these awesome conversations like we just had with Coraline about awesome tech without them. So make sure you reach out and you say hello to them. Coraline, I'll come back to you at the end of the show, so don't go anywhere. The rest of you, hey, guess what? We're halfway through the week, so you still got a couple more days to get the hard work done. Let's have fun and let's build it better. I'm Dave Cooper. Thanks for watching. What an amazing show. Thank you to all of our sponsors for helping us to continue to bring all of these innovative conversations to all of you out there. Please visit them, see what they have to offer you. And as always, subscribe to the YouTube channel and ring that bell. It would mean the world to us. I'm Dave Cooper. Thanks for watching.